Hi everyone, hope you all are good. We are here for grade 10 math. So, we are working on the book Principles of Mathematics, grade 10 book. We're working on chapter 3. Chapter name is Quadratic Relations. So, we're going to start with lesson 3 point that is properties of quadratic relations. So, let's just start with the lesson. Okay, so today we're going to learn the of the quadratic relations. Let me just go to the practice questions. Okay, here I am. Let me just read the key ideas. Okay, the word parabola with equation y equals ax square plus bx plus c is the point on the graph with the least y coordinate or minimum y value. If the parabola opens upward, the greatest y coordinate or maximum value if the parabola opens downward. You can see here this like if the parabola opens upward, then vertex is the minimum value, and if the parabola opens downward, then the vertex is the maximum value. A parabola with equation y equals ax square plus bx plus cx is symmetrical with respect to a vertical line through its vertex. So if you make a vertical line that passes through the vertex, that would the graph would be then symmetrical with respect to the vertical line. The line or axis of symmetry is the perpendicular bisector of any line segment that joins two points with the same y coordinate on the parabola. The x-intercepts or zeros of a parabola can be determined by setting y equals 0 in the equation of parabola and solving for y. You can find the x-intercept if you can put just y equals 0 in the equation. The y-intercept of the parabola can be determined by setting x equals 0 in the equation of the parabola and solving for y. So if you want to calculate the y-intercept, you have to put x equals 0 in the equation. When a problem can be modeled by a quadratic relation, the graph of the relation can be used to make solutions to the problem. So let's just start with question number 1. Check your understanding. Okay, for each graph, state the y-intercept, the zeros, the coordinates of the vertex, and the equation of the axis of symmetry. So you are given with a graph, you have to calculate the x-intercepts, the y-intercepts, the zero, the vertex, and the equation of the axis of symmetry. So let's just with the x-intercept. X-intercept is the point where the graph is touching the x-axis. So here it is, graph is passing through the graph is touching the x-axis on the 2 points. Here you have 0 and here you have -4. So the zeros are 0 and -4. And the y-intercept is 0 because the graph is passing through the origin. So y-intercept is also 0. Okay, just look at the vertex. This is the point, the maximum point, because the parabola opens downward. This point is the vertex of the parabola. So just x is an x-axis, it is -2, and on y it is 4. So the vertex is -2 and 4. And the equation axis of symmetry is the x value, that would be x equals -2. Got it? So the zeros are 0, -4. The y-intercept is 0. The vertex is -2, 4. And axis of symmetry is -2. Got it? Just look at the part B. The zeros are 2 and -2. The y-intercept is -3. And the vertex is 0 and -3. This point is all vertex also 0, -3. And the axis of symmetry is x equals 0. Got it? Okay, let's just start with the question number 4. Okay, examine each parabola. Determine the coordinates of the vertex. Determine the zeros. Determine the axis of symmetry. If you calculate calculated the second derivative, would you differences would they be positive or negative? Explain. Okay, let's just start with question number 2. Okay, determine the coordinates of the vertex. This is the vertex. The coordinates are 2, the coordinates are 3 and 2. Got it? The coordinates are 3 and 2. The zeros are 0 and 6. The zeros are 0 and 6. In the equation of axis of symmetry is x equals 3. Axis of symmetry is x equals 3. And if you calculated the second differences, the second, but would they be, you can just look, see if they are positive and negative just by looking at the graph. The graph opens downward. Got it? That means the second differences would be negative. If you calculate the second differences, they would be negative because the parabola opens downward. If the parabola opens upward, then the second differences would be positive. Got it? Okay, just look at the question number 5. The zeros of the quadratic equation occurs at x equals 0 and x equals 6. The second difference is positive. Is the y value of the vertex a maximum value or a minimum value? Explain. Is the y value of the vertex a positive number or a negative number? Explain. Determine the x value of the vertex. Okay, the zeros of the quadratic relation occurs at x equals 0 and 6. The second differences are positive. That means the graph opens upward. Upward, got it? Because the second differences are positive. And also because the graph opens upward, that means the maximum value, the is minimum value. Got it? Because the graph opens upward. So the vertex is a minimum because the curve opens upward. Okay. Is the y value of the vertex a positive number? Explain. Because the vertex is minimum, so it must occurs below 0. That means the y value must be negative. Got it? Okay, determine the x value. So you are given the vertex, the 0 and 6. Got it? So just add them and divide them by 2. 0 plus 6 divided by 2, that means the x value would be 3. Got it? Okay, let's just start with question number 7. Create a table of values for each quadratic relation and sketch its. Then determine the equation of axis of symmetry, the coordinates of the vertex, the y-intercepts, the zeros, and the maximum or minimum value. Okay, the first equation is y equals x square plus 2. Let's just graph. You can make a graph first by making the table, but because I have an on tool, I can. Okay, here is the graph y equals x plus 2, x square plus 2. You can see the parabola opens upward. Okay, let me just see the questions are. Okay, x equals 0 and the vertex is, you can see here is the vertex is 0 and 2. Got it? And The y-intercept is 2. Got it? So the graph is opening upward. That means is what its vertex is above the x-axis. There are no zeros. So the minimum value of the graph is 2. Got it? Okay, the next one is let's just do e part. Y equals x square minus 2x plus 1. X square minus 2x plus 1. Okay, here is the equation. Here is the parabola. Here is the vertex of the graph, that is x is 1 and y is 0. Got it? So that means the x-intercept is 1 and 0. Got it? The y-intercept is 1. Also, the parabola opens upward, so the the vertex has the minimum value. Okay. Same things you have to do with question number 8. Use technology to graph each quadratic relation below, then determine the equation of the difference is for this question 7. You have to make tables in sketch graph. For the 7, you can use technology, like you can use any online tool to make the table. Okay, let's just look at the question number 9. Each pair of points is located on opposite side of the same parabola. Determine the equation of the axis of symmetry for each parabola. Let's just start with question number 9. Okay, the points given are 3, 2, and 9, 2. Let's just start with question number 9, 3, 2, and 9, 2. Okay, first of all, x equals 3 plus 9 over 2. That would be 12 over 2 equals 6. That means the axis of symmetry is 6. Got it? So the axis of symmetry is 6. Okay, the next one is, okay, use graphing calculator to answer questions 12 to 15. A football is kicked into the air. Its height above the ground is approximately the relation where h is the highest height in meters and t is the time in seconds since the football was kicked. Part A is what are the zeros when does the football hit the ground. B is what are the coordinates of the vertex. C is use the information you found from part A and B to graph the relation. Okay, let's just start with question number 12. Okay, okay, hold on. The equation is h equals 20t minus 5t square. Okay, so to determine the zeros, we're going to put h equals 0 in the equation. So 0 equals 20t minus 5t square. You have 5t common. You are left with 4t minus t equals 0 and t equals 4. You have two values for t. So the zeros are 0 and 4. That means the football starts on the ground at 0 and will hit the ground at 4 seconds. Okay, the second one is what are the coordinates of the vertex? You have to calculate the coordinates. Okay, e value of the vertex is midway between the zeros, so it would be t equals 0 plus 4 over 2. That because that is the middle one of the zeros. So t equals 2. Okay, when t equals 2, just solve the equation for 2. H equals 20 times 2 minus 50 times 2 square, 5 times 2 square, sorry, not 50. Okay, for 20 times 2 is 14, 20. H equals 20. That means height equals 20. Okay, the next one is question number 14. An inflatable raft is dropped from a hovering helicopter to a boat in distress below. The height of the raft above the water in meters is approximated by the equation y equals 500 minus 5x square. The height of the raft above the water in meters approximately by the equation y equals 500 minus 5x square, where x is the time in seconds since the dropped. What is the height of the helicopter above the water? Okay, the equation is y equals 500 minus 5x square. That is question number 14. I am sorry, but I am not feeling well. That's why I am too down. Question number 14. The equation is y equals 500 minus 5x square. Okay, so for the A part, you have to calculate that before the water. So you have to put x equals 0. When x equals 0, y equals 500. That means when x equals 0, it's 500. The helicopter is 500 meter above the ground. Got it? Okay, the next one is what when does the raft reach the water? What is the height of the raft above the ground water 6 seconds after it is dropped? Okay, the raft reached the water when y equals 0. So when y equals 0, 0 equals 100 minus 5x square. You have to move 5x square this side. 5x square equals 500. Divide both 5. It would be x square equals 100 and x equals 10. That means the, the raft reached the water 10 seconds where it is dropped. Okay, the next one is what is the height of the raft above the water 6 second after it is dropped? So you are given time equals 6 second. So x equals 6. Just put time in the equation. Y equals 500 minus 5 6 square. 500 minus 36 times 5 is 5 times 6 is 30. 5 times 6 is 30. Hold on, 36 times 5. I am 180 and 500 minus 180 is 320. Got it? That means after 6 seconds, the height of the helicopter is 320. Got it? Okay, let's just start the next one, that is factored form of a quadratic relation. Let's just start with the practice questions. Okay, let's start number 4. Determine the y-intercept zeros equations of the axis of symmetry and vertex of each quadratic relation. Okay, let's just start with question number 4. Okay, the first equation is y equals x minus 3 times x plus 3. Y equals x minus 3 times x plus 3. So first of all, you have to calculate the y-intercept. Just at x equals 0, it would be y equals 0 minus 3, 0 plus 3. So minus 3 times plus 3 is negative 9. Let's just calculate zeros of the equation, that is the y-intercept. Okay, for the zeros, just x minus 3 equals 0, x plus 3 equals 0. So x equals 3 and x equals negative 3. You have two zeros. Then for x's of 3, just add zeros and divide by the 2. So that would be 0. That means the axis of symmetry is 0. You have to calculate the vertex, that is the axis of symmetry. Okay, you have to calculate the vertex y equals x minus 3, x plus 3. Just set x equals 0, 0 minus 3, minus 3 and plus 3. So minus 3 plus 3 makes negative 9. That means the vertex is 0 and negative 9. Got it? Okay, let's just look at question number 7. Determine the zeros equation of axis of symmetry and vertex of each parabola. Okay, zeros are 40 and negative 40 for this one. The vertex is 0 and 40, and the axis of symmetry is okay. Just look at the question number 10. The x-intercepts of the parabola are negative 3 and 5. The parabola crosses the y-axis at 7 -75. The equation for the parabola determine the coordinates of the vertex. Okay, so the parabola crosses the y-axis at -75. Got it? That means it would be 0 and -75 is the point on the parabola. So determine the equation, insert the zeros, the y-intercept into the general factored form and solve for a. So it would be y equals a x minus r x minus s. Y equals a x plus 3 and x minus 5. Y is -75 and x is 0. Just replace x with 0. Then you have -75 minus 15 times a, divide both sides by 15. A equals 5. So the equation y equals 5 times x plus 3 and x minus 5. Got it? Okay. Question number 11 is sometimes the equation y equals a times x minus s cannot be used to determine the equation of parabola formed its graph from its graph. Explain when this is not and draw graph to straight. So y equals x minus r and x minus s. R and s are the zeros of the equation. Got it? So this not been used if there is no zeros. This occurs when the quadratic form cannot be factored using numbers. Got it? Okay. Question number 14 is Ryan owns a small music store. He currently charges $10 for each CD. At this price, he sells about 80 CDs a week. Experience has taught him that a $1 increase in the price of CD means a drop of about 5 CDs in sales. At what price should Ryan sell the CDs to maximum his revenue? So X is the number of $1 increase. Then the increase in the price is 10 plus X. So the equation is R equals 10 plus X times 80 minus. Okay, so we were working on grade 10 math. The chapter we were working on is, let me just see the chapter name. Graphs of quadratic relation, that is chapter number 3 on the book. The page is 134. Okay, we're working on chapter 3, graphs of quadratic relations, and we have covered the lesson 3.2 and 3.3. They are properties of graphs of quadratic relations and factored form of a quadratic relation. So please make sure before the next session you can complete all the test questions for the lessons we did. So if you need more help with the lesson, you can contact any tutor on the Skype. They are available from Monday to Friday, 5 to 9. So that's all for today. See you in the next session. Bye everyone.